So, playing video games one frame at a time. And I'm Ólafur Waage. This is my face. I'm a senior software developer at Factlines. And luckily with an Icelandic name, there aren't that many that have the same handle as you. So I'm this username on most platforms. I'm all over the place. Not on Twitter, though, because Twitter doesn't exist. I work for Factlines. We deal with supply chain compliance. So discover your sustainable supplier networks of like getting follow-ups and risk levels. Half of you are going to be, what on earth is this? And the other half are going to be, this is so tricky. And if you're in the second half, you should look us up. That's what I thought at first. Like, what's this? And then, yeah, it's very tricky. Very tricky. All right. It's been a theme over the past couple of years. If I start every talk with a philosophy quote. And this one is, people say nothing is impossible, but I do nothing every day. And this is, of course, the famous philosopher, Winnie the Pooh. And that's been also the theme. All the quotes that I've been using are Winnie the Pooh quotes. Look them up. They're very philosophical. There we go. That's a word. So, who is this person on stage? That's a picture of me when I was younger, which is a great joke. I worked in air traffic control systems for a couple of years. Wrote these, overflight systems, and yeah, it's very tricky stuff to code. And then I worked in the gaming industry for 7 years. I'm there somewhere. You can find me. But trust me, I am there. And then I was I was a consultant in Norway for a couple of years, and then now working at that Factlines company in Norway. And I occasionally yell at people like I'm doing right now. Good. So, what is this talk about? Because you're probably intrigued by the title, right? So, a good way to describe this talk is, it's a bit of silly fun, right? It's a bit of curiosity, like a little obsession of mine. And there is a real-life use case that you might be able to use even if you don't work in games, right? So I'm going to give you that one thing, but it's mostly the first two, right? It's like an 80-20, right? Okay. So, and also, this is probably not an area a lot of people have thought about. Maybe one person there in the front row that has probably thought about this. I know he works in games. Also, last year, my big talk last year was way more serious than this one, right? And it was about how humans learn information. That was like the main point of the talk. It's on YouTube if you want to watch it. It's called Learning Rust the Wrong Way. It's not much about Rust, it's about learning. And in that talk, I said this, and you can cut into this video of like a video of me when I was younger, like, oh. Unfortunately, in this case, there's considerable evidence that in many situations, that this strategy, the 1-hour lecture, is rather poor. This is from 1971. We've known that lectures for learning is not good since the 70s. A lecture may inspire, it might motivate, and it might inform, but it rarely fulfills the principle for effective learning. It's certainly inadequate for developing high-level skills. All right. So, I cannot, in good conscience, make a talk the next year that tries to effectively teach you something. I might do it the year after, when everybody has forgotten about the first talk, but so instead I decided to make a fun talk, but that has some real-life applications. So we're going to have fun along the way, and then you'll be like, have a little one nugget in your head, be like, oh, okay, I could maybe think about that. Also, here's a lot of preamble to this talk. Before I start, I will do stuff to video games in this talk. If you're going to do similar stuff, please, and I'm asking nicely, only do this to single-player, non-online games. Yes, a lot of people will thank you for that. It's not crazy stuff, but it's like, I feel I need to add this warning. All right, cool, that's preamble done, okay. I have about 300 slides, so we're gonna keep going, right? So, boring backstory. Playing video games is a great fun, but also, I'm a programmer. So, how can I marry these two things together? How can programming and video games ever come together as a whole? Well, you can make games. Well, as you saw, I worked in the game industry for 7 years. Okay, done. But what if there's another way to put together video games and programming? So, games are just applications. Often, sometimes very boring applications, but what they do is fun. So, what can we do to control these applications remotely. What are the different challenges you will face by doing this when you're trying to interact with complex software like this? So even though sometimes what the games are doing is kind of boring, there's a lot of it. So it can be very, very complicated. So, and can some of this apply to interacting with other software? Good. And since I'm talking about video games, I have to be on theme, so this is level 1. All right, we're going to level up. What if the game I want to play supports this? Supports playing it programmatically, right out of the box, right? Who can think of an example of a game that does this? Yeah? 1 billion humans. There's a lot of these sim games that are really cool at this. Let's talk about Doom. Yeah? Who here doesn't know what Doom is? Oh yeah, there we go. So Doom, I'm going to explain it anyway. So Doom is a 1993 first-person shooter, all right? And it kind of redefined a few aspects of video games, okay? The look and feel, I mean, some of the earlier games kind of did that, but generally Doom is what people are looking at when designing these games. Online multiplayer and game modifications. So there's a lot of things that one game did. So no wonder people talk about this game like it's some holy grail, right? But there's also another thing this game kind of redefined. It's video game speedrunning. Aha. And in this talk, I can't go over everything, but I'm going to look at the last one, right? Who here has done a speedrun of a game? Any? Oh, very good, very good. You will like this talk. So let's talk about psychology. Whenever there's a timer, people try to be the best, try to be the fastest, right? Nobody here, everybody here competitive? Yeah, of course. And Doom is no exception. After every single level, you get a timer. And you also get a par, which was the developer's time. Ooh, now we gotta beat the par, right? Also, I love this screenshot because they got no kills, all the items, and all the secrets in a minute on some level. Like, okay, that's pretty cool. So, because yes, at the end of the stage, there was a timer. And as you can see, people are still playing, and people are still trying to get better. There's a time there from 2019. This is just an example. People do stuff to this day. And there are these files, these zip files. So E1M1 hanger, Alexei in 2019. There's E1M1, and then P897, which is, if I looked at it correctly, is the number of attempts he's done. So he's done a couple of attempts. But yeah, good stuff. So let's download this file, right? We're curious. You notice that they're pretty small, a few kilobytes. And of course, from the 1993 internet, this is great. You're going to have the files pretty small. These are called demo files, even though the extension is .lmp, so they're lumps. These are usually called demo files, and you can play them. Because these files only contain the inputs that the user pressed and during what frame. During this frame, they press this button. During this frame, they press this button. That's the only information that's there. This is the header of the file. It looks like this. You're defining the name, the version, if any expansion packs, any of the flags they might be setting, and any of the multiplayer sets. And then a little bit of a player state information. So that's the header. And then every line is a packet that looks like this. If you're moving forwards or backwards, strafing, turning, and then some of the actions you can do. You can shoot a gun, you can open a door, yada, yada. Which then means that you can't shoot a gun while you press the button to open the door. But I mean, it's a game from 93, so that's fine. And that's it. That's the data. And you can load a program that's called XDRE, and you can see the lines moving forwards and strafing, pressing some buttons. And if you play them frame by frame, you can watch the game unfold and all the statistics and information that's happening here. It's pretty cool. Doom supported this from the get-go. 93. This is possible because of one thing, and this is the game loop if you're curious about reading. Doom is deterministic. Okay? Doom is a single-threaded application where every single entity in the map patiently waits their turn and always in the same order. There's more of the game loop if you're curious. You can press screenshot now, right? Okay, no. And when they want to do something random, it's very simple. They pick a number from this table. That's the only thing they do. It's a pretty random table, right? Seems to be random enough. And this index here at the bottom, there are actually two of them, but this index over here will be incremented. And then the next time some entity wants to do something around them, they get the next index. And then it's just incremented and incremented. Cool, right? That means that if I play a game and save the file, and you load it up with the same version as I have, there you go. We have a deterministic view of the world. Great. This is 93. Good stuff. So, what if you wanted to take Doom and convert it to C++ or some language, whatever you want to do, right? This was initially started by Jason Turner, where he did a 400-hour live stream on YouTube to try to convert Doom to C++. He didn't succeed because even though Doom is an old game, it's still pretty big. And then Patricia Oz got the same idea and took his fork and said, like, okay, let's try to keep going. And since I was working with her at the time, I was dragged into the mess, or the fun, if you want to compare it. And I'm like, okay. She compiled the game, did some changes, compiled the game, and then I asked, cool, did the thing you did work? Did you break the game? And she was like, I don't know, I haven't run it yet, because she hadn't played it. She was more interested in the coding part of it. So I showed her how to play it, and lo and behold, we had broken something. Okay, cool. How can we make sure that that doesn't happen in the future? We need to make sure that she can go and just go nuts and do all her fancy refactoring, and then the game is kind of okay after all, right? So, how can you move forward on that project knowing that your code changes and refactorings haven't broken the game or the project, right? We could try playing the game, sure. Is that going to cover everything? Probably not. We can write unit tests. That can help some of it. We actually wrote some of them. But we have that tool in our hands right now, right? So, there's a thing called approval testing, for those who don't know about that. It's a methodology where you focus on comparing the output of the old known bit of code with the output of the new one. So, think of it kind of like a git diff. You get the output, you have a bunch of output that you know is good, you do the output of the new one, and if there's any difference, we don't approve of this, right? So, this is useful when you want to do a complete rewrite or when the original source code might not be available. Good stuff. Doom can run the old demo files, and if you give it a flag, it will output this kind of little statistics screen, telling you what level, how long did it take, and what did you do, similar to the other screen. Cool. Yeah, the thing I said. All right, good stuff. Well, and if I play the demo on the new version, I should get the same file, right? All right. Another tidbit, the game doesn't need to render anything, because the rendering is just a pretty output of the simulation that's happening. Some of you are like catching along what's happening here. Yeah, the graphics are just the nice thing, right? Then we can add and modify some of the flags that we have to get the game to run terminal only with the demo files. This also means that we don't need any of the sleep functions or whatever. We can just run the game as fast as possible because it's deterministic. So we just go through the whole thing, right? The simulation is the same. So, putting one and one together. You play the game with a good known version. You collect the outputting stats files. You save the stat files next to the demo. You write some bash, because of course, you hack something together with bash. That's always how every good things get done, which then runs the game, makes the new output file, and does a diff of the old output file with the new one. And if there is a difference, exit 1. Cool. Or AKA, Doom running in GitHub Actions. So, a lot of the setup is thanks to Patricia, doing all of the versions in the release and debug and whatever. Fun fact, loading the game in 64-bit and then creating a save file and then loading the save file will crash the game. Because the game actually saves the pointer addresses in the save file to recreate the same structure you had in memory. It doesn't use the same structure, it's just to know which thing was the next thing in the linked list, right? So if you save a 32-bit file in a 32-bit version and load it in a 64-bit version of the game, it doesn't work. Vice versa, yeah. That's still an open bug, but I don't think the Doom people care. But anyway. So we can build it. You can see that building took 10 minutes, and there's a fourth to the bottom, is demo check. It took 0 seconds. Even though I'm running I think 10, 15 demos, it takes no time to run. And here, for those who have run Doom in the old days, remember this little thing? We actually do have the shareware version of the Doom WAD file in the GitHub because it's shareware, so we can share it. So all the demos are running on the shareware one. But yeah, runs the game, does the diff, works fine. And then we have an all-green build. You know that the thing you did is good, right? Cool. So now we programmatically run Doom. Good. All right, we've leveled up. Game number 1 done. What's our time? Ooh, it's good. Good time. So, level 2. What if the game you want to play doesn't have the support that Doom does? Now I want audience participation. Bejeweled. Who's played this game? Or who's not played this game, maybe? Maybe a better one. Ah, okay, 5, 6 hands, good stuff. Then I can teach you what Bejeweled is. Because this will be your new addiction. It's a great game. So Bejeweled 3 is a match 3 game. It's not the 3 that matters, but anyway. Where you pick a gem and move it left or right, up or down, to make a match 3 or more, right? That's the only thing that happens. When that happens, those gems explode, and the gems above it move down. Simple as that. You get points, you move on. Very good stuff. You can also join 4 or more, then you get a gem that's on fire, and then that explodes with a bigger one, you get more points. And you can do other crazy joins, and there's a special gem, and yeah, lots of fun things. After a match has been made, the gems go away, and new gems drop down. Good. So, I need to play Bejeweled 3 automatically, because that's my need right now. And the plan of action is very simple. What gem is where? That's the first thing we need to do. Because we need to find out what is the stuff we need to move. We need then to pick a good move, whatever that means, right? And then we need to move that gem. Simple, right? What is where? What should we move? And let's move it. Cool. Have a loop. Good. The project is C++, CMake, VC package, and OpenCV. It's not that much code. It's like a few pages. And OpenCV, for those who haven't used, is a computer vision library. I used this. Initially, I only used it for getting a screenshot of the game. But you will see I use it a bit more later on. But I mostly use it to capture the screenshot of the game. Or to work with the pixels after I capture the screenshot. Yeah. So, step 1. What gem is where? So, if you have a modern monitor, like I have, the game can kind of run in a bigger resolution, but if you run it in 800 by 600, it doesn't have the super special fancy effects, and there's a few other benefits you have, but that also means that when you're working on it, it looks this big, which is not great, but it's okay. So for your benefit, I will make the screenshot bigger. So first of all, what gem is one? If you play on the 800 by 600, every single gem is 64 by 64 pixels, which is a great number, of course, right? Yeah? Yes, good. This also means that the board starts at 261 times 37. That's where the game board starts. So if I then just extrapolate, I know where each gem is. I know the center of it, they're always the same size. Nothing happens like, there's a bit of an explosion effect, but we kind of don't care about it. But from this information, I know at least where they are. But what gem is it? So how do I know that this is the green gem, right? That's the problem I want to solve now. So, like with any computer stuff you do, let's start simple. Let's just look at the center pixel, because they're all occupying that center area. So let's just look at that color, and if it's the greenish thing I want to have interest on, then that's the green one, right? Right? Yeah? There's a problem by doing that. Because if you click the gem, it spins, which is great for the game, makes the game really fun. But for me right now, that's a problem. So what do? Let's use this OpenCV that I used to get the initial pixel data. They have a thing called template matching. So I thought, like, hey, let's be cool. The gems, like, each one of them has like its own shape, has like its own color and everything. They are kind of distinct. I know where they are, so I can create these templates. So this is a photo of Messi. This is from the documentation from the OpenCV library. They want to find that very excited photo of Messi over there and try to find that in a bigger picture. All right? So I have a thing called template matching. So what they do is they have, this is the output result, this is the matching result here, and the higher the color, the more confident it is that the picture is there. So they know that Messi is there because the most brightest color is in that spot. And again, with a lot of these things, this is the statistics. So what's the likelihood of the photo, of the template being here? Not very high because the color isn't so high. So there's always some place you can find, right? So, and they have different kind of coefficients they can apply on the output image, but it's kind of the same. You get kind of similar results. Good. So I used this, try to find out where each gem is. So I went out and created a bunch of templates. Don't worry, they didn't look like this, but I just took a couple of screenshots for the slides. But I got a few of the templates, get the images, and then I have the application, and then I have the application that's detecting the templates. Who can see the problem? Show me hands. Problem. Yeah? One missing. Why is the one missing? Can you? So, yeah. So there, you can see on the yellow below it, because I had the application running for a little while, and the game is like, well, this user isn't very good at the game because they're not doing anything, so I'm going to give the user a hint. Hey, user, if you move that yellow one, something will happen. So it's like putting an arrow on the yellow one, which messes up with my template matching. Right? This happens once in a while, so it's not great, but you can see I have a threshold. So what if I just mess with the threshold, right? You just find a good number and that works, right? No, then I'm too greedy. So then this glowing orange one is kind of too much like the red one, apparently according to the matching one. So this doesn't work. I tried different algorithms, different coefficients, different thresholds. I spent like an evening on this. This doesn't work. And I'm trying to figure out like why doesn't this work? Well, the thing with this algorithm is they make the images black and white, which kind of kills one of my advantages is that the gems are all separate colors. And a lot of these algorithms use black and white. Some of them use color, but yeah. I thought like I'm going to have a problem going forwards if I have this issue here. So there must be a better way. Must be like if I go back to the simple world. So let's go back to the idea of color, because that's definitely where my advantage is, right? What if I don't check for one pixel in the center? What if I check for the general hue of the area? So I grab a 32 by 32 pixel area of the center, and then I ask OpenCV, what's the average color of that area? So if the gem spins, the color is gonna go up and down a little bit in the hue, but it's gonna be roughly green-ish, right? So, and I check against the hue, saturation, and value of the color, and not the RGB. What will happen in the future? I will actually also use the RGB as well, but let's start with the hue. So I've turned the problem into a linear algebra problem, because now I just have an arrow. I have a vector that points in this direction. It's not a vector, but it's a number, but you think about it that way, that the green gems are roughly going to be in this area, right? Who thinks that's going to work, right? I have 5 confident, okay, a bit more, thank you. Good. So we checked so this was another thing that was a fun one. I had to go and click on every gem and record the hue values into a file and get the average number, get the max and the min number, and do this for every gem, do this for every shining gem, do this with gems and different background elements. So this took like another evening of just collecting the data. But I made a chart of what is the max and the min of the hue value of each gem. And you can see for a lot of them, they don't overlap. Like the orange and the yellow one was kind of like on the edge. And you can see with the red and the purple, there's a part where they do overlap. But hey, a lot of it is decidable. So then I wrote a very complicated function, an incredibly complicated function that just takes in the 2 scalars, the hue, saturation, value, and also use the red, green, and blue to just help disambiguate, fetch them out, get the values, and this is a very complicated if statement. If the hue is roughly between those 2 values, then you are blue. And then I just keep going on. Like if you are between these, you are green. If you are between these, etc., etc. I simplified it a bit because it's like was mixing things together, but you get the idea, right? So, you think this works? Huh? Yeah, beautiful. There's one gem where this doesn't work, because there's like this super gem that's like black, and it has all of the colors, and it spins. So, but don't tell anybody about that one. That's we can ignore that one. All right, but yeah, this works, and I get all these beautiful colors. And if I play the game, and I did like sample tests on this, then yeah, I get the correct values out. That was step one. Step one, where are the gems? Because step two is pick a good move. Because what's a good move? Who knows, right? Initially, again, like, oh, let's do some cool algorithm, deep learning, yada, yada. But after all the color fiasco, I'm like, no. Let's see if something simple works first. And it was. So this was a great excuse to go and play the game, because I hadn't played the game much before that. Like Patricia, like, no, I'm interested in colors. Who wants to play video games? So I played the game a little bit. Only 14 hours, which isn't much in many cases, but yeah, I played the game a little bit. I haven't recommended it yet, but we'll see, maybe in the future. And I had an idea. There aren't actually that many moves in this game. When I was playing it, of like that, there are just a handful of basically not moves, but well, only 4 moves. Like, what are the set of matches that can happen? And there aren't that many. You can match 3, you can match 4, and 5, and then they have a little bit of variation of where the gem is. So can't we just map all of them out? Can I just make a list of them? So I did. So I made a little format, very simple format, where I have the idea that I want to make A, B, and C, but there's some X in the way. It looks kind of like this. So the C is always the point that I want to move, and the A, B, and other letters are the point that are stable, that are not going to move. So we're always looking for the C. So I push in the points that are the A point and the B point. So the A point is basically the origin, and then the B is -1 in the X from that one. And then the C is then -3. I call it something, give it an enum, and then I have the solution. So if you have this setup, where it's 0, -1, -3, the solution is to do this kind of math operation. You do +1 on the first column. You do nothing on the second column. That's how you solve that one. So if you ever detect this setup, then this is how you solve it, right? I give an ID, and then I give it a value. So this value has 1 because, and I put it in a list, because if there are more complicated setups that have more gems in it, so A, B, E, D, and then the C comes in the corner, I put all of them in, and the C is the last one. It's called corner 5. You do a -1 on the last one. It's ID 30, and I give it a value of 3, because if I find this one because what I'm creating an array of all the colors, which are just the character values. So if I find this one, and I also find the other one, I want this one first, because this one has more points. This is more valuable. So I give it a value of 3, which is just some value. So, and I don't know if this is fate or whatever, or I probably missed some. There are 32 of them, which is kind of like, as a programmer brain, like, wait, that must be wrong. But maybe there's some mathematical higher thing about why this is 32, but there are. And then for every image that I'm looking at, I go through, I find all of the possible solutions of this current state, and then I sort them, and I pick the top one. That's it. And then I perform that action. So, but which one of them should I pick? So, okay, I do the sorting, but there's one other thing. Yeah, higher value moves are always sorted above the lower value moves, but what if all of them have the same value? Well, then I pick a move that is lower on the board, that has a higher Y value, because it's lower on the board. Because it creates more opportunities, because when the gems break, the column moves down. And if the column moves down, there's more opportunities for like an automatic match, because there's more stuff happening. If you match at the top one, only one row is going to move down. If you get the bottom one, you get way more, right? So I pick that one, and if there's 2 in the same row, I just pick whoever I decided to be first. That's fine. So step 2, way easier. Step 3 is even easier. Move that gem, because now it's time to interact with the actual application. So the Windows SDK has a lot of nice mouse input functions. So let's just use them, right? I basically want this function. I have the window, because I have the handle. I know where I have to start, because I know where all the gems are. And I know the distance, the offset of where I want to move to, because I know what move I picked, because there was a solution to the earlier problem. So, and this is one that someone can come and help me out later. This is the function to get the mouse position when you have an absolute window. So sorry about the nerdy technicalities, I say in a programming conference, but I have to do this. And I try to use client to screen or screen to client or whatever. It doesn't work. I have to do this magical multiplication or division or whatever I'm doing just so I can do the cast of the mouse position of where I am. So if you have a simpler way, let me know, or do a pull request. There's a thing at the end. But anyway, this is a way to get the mouse position from the... I want to get the game world position of the mouse, right? So, and this is going to look like a lot of code, but this function is actually pretty simple. I called this function I called before, so now I know where on the screen I want to start from. I move the mouse to that position. So I create a move object, give it the values, say it's an absolute coordinates, and I want to move, and I then send the input. And then I click the mouse. I get the same coordinates for the end position. I move the mouse. I release the mouse. That's it. So this is a wonderful function that takes up a lot of code, because who doesn't love a lot of code? All right. So who wants to see this? Yes. All right. Good stuff. Well, too bad. No, I'm kidding. So I have the game here running. Been running the whole time. And I want to make a new game. Here it is. I can have fun. I'm sorry, I'm just going to play the game. No, I'm kidding. And then I click this. And demo gods. Yes, there we go. Yeah. So here's the thing. Oh, we got the black one. Good. It matched it. Of course. Yes. Very smart. Smart AI. So it finished the level. And then it just continues. Just plays the game. I've gotten it to go through multiple levels. Thank you. And I have gotten a couple of times where it gets stuck, but that's pretty rare. I just make it loop X amount of times. There's another thing I haven't talked about, which is, if I go to, I think it's in window, of course, I can do this. I'm searching for sleep. Oh, here it is. It's a big S, sleep, yeah. I do it 100 times. I do an update, and then I do a draw, and then I sleep for 300 milliseconds, because it's too fast. So there's a thing with the game, is that if you do a match and stuff is falling down, you can do the match in the air. This is the thing I learned about the game. The game doesn't lock the state of the world when it's doing the moving. So I've seen it do like crazy stuff where it's like matching things in the air or doing another column while the other column's falling down. And so for demonstration purposes, I make it sleep so it looks more like a human, but it's too fast. That's the other thing. Because I thought it was like it's doing a, yeah, you gave me a hint. I thought it would be like taking a screenshot, doing these analysis, and no, it's very fast. So it works pretty well. And there's a link to the repo after the end if you want to have fun like I did. I haven't done any measurements on it, but it's it's clearly more than 60 times a second. Like it's very fast. Oh, that one I haven't actually looked at. So this is, you can go and try it out. Go play with it. Yeah. So, should we level up? What's our time? Ooh, our time is good. Let's level up. What if the game has none of this? Right? So, who's played this game? I asked instead who has played this instead of who has not played this, because there's probably not a lot of. So I got like 3-4 hands who has played this game. So this game is called VVVVVV. Yes? So I'm just going to call it V, just for the sake of brevity. It looks kind of like this. This is like a demo level. It's a platformer, and the gimmick is that you can't jump, but you can invert the gravity. So, and then, of course, spikes are bad. So you click the spacebar button, and it flips the gravity. And you, of course, want to avoid the avoid the spikes, and sometimes get these little trinkets and have a little fun. So it's a platformer game. It's a lot of fun, and I recommend. So this game does not have built-in support for giving the game inputs. All right. So I thought, like, hey, I can use something like the Bejeweled setup, but the game doesn't have a simple game state like the Bejeweled game, because you're going between screens, there are different levels. Yeah, there's a lot of things you have to look out for. And also, like, each level has like different color themes and different patterns, so there's a lot of things you have to look out for. So it's fast-paced. You need to be pretty accurate with your movement and do all these things. So I thought, do the pose. I thought, like, hey, I'm gonna be hacker man. I'm gonna do something really cool hacking. What ended up happening is I was more like this, because yeah, this is can go pretty weird. One thing before I continue, because not everybody has worked on games, there's one concept I need to talk about. That is the game loop. All right, games are applications just like anything else, and they usually follow a certain set of steps. They get the input from the user. They update the state of the world, and then they draw the state, right? That's what generally the idea that's happening. There's a few caveats that can make this harder, and there's probably more. So a lot of the stuff that I'm showing you has probably an asterisk at the end of it. Getting the input from the user, well, there might be no input, or if you handle the input badly, it might delay it, or we might miss it. Like if someone captures the input or grabs the input before we do. Updating the state can take a long time sometimes, and also might be multi-threaded, or when it happens might be hard to find out. And drawing the current state. I mean, we might be drawing the old state, or it might be offloaded to the graphics card, or you have no idea what's happening. So a lot of it depends here. So, but usually what's happening is you initialize the game, you process the input, you update the game state, you draw the game state, and then you go back up. And this is usually called a frame. This is usually less than 1 millisecond. And the fun thing is, how long this is, it depends. And how long this is, it depends. But for many games, you want this to happen, at least part of it, with 16.66 millisecond delay, right? Or at least update the game state every 16 milliseconds, or however fast you want the game state to run, because this can then be run as often as you want. So games do different things. Here's as an example. There's a whole slew of theory about what a game loop should look like, but just to give people examples, so we can get some initial data and clock time. We have an infinite loop, because of course we have. We get the time, and we accumulate the time, so how much time has been spent. We process the input, and then we ask, while the accumulator is more than delta time, we might update the game state with the delta time. We decrement the accumulator, so we've processed one section of the time, and then we might draw the game state. So in this example of a game loop, we process input as often as we can. We sometimes might not update the game state. We sometimes might update it many times, but we try to draw as often as we can. And in some cases, when you process input, you might also sometimes not always like deplete it from the queue. You might say like there is input to look at, but there are many ways to do this. So we process the input. This thing, because if the loop is happening, or we're running through it every 1 millisecond, then every 16 times this if is going to hit. So we're going to say, okay, let's run this one time, then we subtract one duration from that. You might also owe time. Sometimes that happens if you click the status bar on the Windows, the application kind of freezes, and then you let go, then you've owed a bunch of time, so you update the game state that way. So anyway, and then you draw the game state. So V actually has a few advantages, and it's kind of why I picked the game for that project. It's open source, so if there's any questions that I have, I can just go and check. So here's the loop, and there's a certain thing about this loop, because it's asking for what's called over 30 FPS mode. And the game actually has one of the advantages that makes solving this problem easier is that it does one input check, one update state of the game state, and then one draw every frame. Always does the same thing. And then it sleeps for the remaining time and goes back up. Not all games can do this, but this makes our problem solving way easier. So it's single-threaded as well, and it has a lot of customizations. It even has speedrun options. So if you want to go do speedrunning, you can do that. So here's my plan. I'm going to launch the game in a paused child process of some loader. So I have the game process. So now the game process is a child process of me, and I will inject the DLL into the game process. I will then hook the function that creates that DirectX device, which is the thing that the game uses to draw to the screen. I will get the address of that device, and then intercepts the game's draw call, and then call our draw functions and my code, whatever I want to do, first. And before each frame, I will then send to Windows my keyboard inputs, because then, after the game is finished drawing, the next thing it does is looking for inputs. Then it's my inputs I sent before the previous frame. I will go on and have fun. So if you go back to this image, I'm hooking here. I'm intercepting the game's draw function and sending our inputs. Some of you might thought, wait, couldn't you just hook the input process? Like that's the place where the inputting happen. So you put your input there, and then you let the game do the inputting. The reason why we do it down there is also we want to draw some debug UI. So that's a nice place to do it. So we intercept in a draw call because it's going to happen anyway, the input checks. All right. So another thing you might think is, wait, that's illegal. And Windows thinks so too. Operation did not complete successfully because file contains a virus. Because, yeah, this is what viruses are doing, or some of them, not all of them, but yeah, this is very virusy behavior. And the issue I had was I could not run this by the life of me, except like turning off Windows Defender, which I didn't want to do. But the benefit was there is a way to do hooking that the Windows Defender doesn't yell at you. I don't use that way because when I did the talk previously, someone mentioned there's a different way. Also, it doesn't happen in debug mode. So what you're going to see is debug mode. That's what you're going to look at. All right. I use detours, and the other way is there's another hooking package that you can use. But detours is from Microsoft, and it's a bunch of helpful utilities to do this kind of thing where you're injecting code into other code. So, and detours, that's kind of a fun way. For those people who haven't done this kind of things, usually the idea is you need the address of the function that they are going to call, and then you place that address with your basically function pointer. And then when they call your function by accident, because you changed the address, your function is called, and then you can call their function. So you can do your stuff either before or after their function has been called. That's kind of the idea of what we want to do. And for those who haven't done any DLL stuff, we initialize detours. So there's a DLL main, and usually when you have a DLL main, you have an attach enum that happens, because the DLL main might be called many times. So you have a reason for call is an attach, or a reason for call is a detach, and then you can do your stuff in that place. That's kind of the idea. I won't do it this way, but if someone wants to have fun with DLLs, this is kind of the things that are happening. So again, also I thought, okay, I need to do all this like DirectX 9 because that's what the game is using, like hooking of the draw calls and la la la. Isn't there someone who has just done this? There must be someone on GitHub that's just done this stuff. So thank you, Tom Gascoigne. And if you're watching this video, you're very helpful. Your code from 12 years ago was basically the basis for this project. And I like his last commit. Whoops, forgot to commit the new class. Same. I have been in your shoes as well. But this was a very bare bones way of the only thing he was doing in this project was just hooking the draw call and printing some stuff. So I was like, great, this is exactly what I need, which was good stuff. So what I do is I need to know what DLL I'm loading. So I have that saved there, and what the flags of the application I want to start. So I want to create an application that's suspended. So Windows is going to spawn the process of the game, but the process isn't allowed to do anything. It isn't allowed to continue until I say so, basically. And then I create that process, but what happens is my DLL is allowed to do things, but the game process is not allowed to do things. So I can run my code, but the game isn't allowed to run their code. And then at some point, the thread is resumed after I've done my stuff, and then we'll wait forever until the game quits, and then I have a little exit message at the end. That's kind of the structure of my code. So my DLL main looks something like this. I will call a function I call hook create device, and then I will go away. That's the only thing I do. I don't do any cleanup because I own the process. It's not a process spawned by someone else, so I don't have to care too much about it. And you get this. You can notice that I have a message box A for an error message. If you're doing DLL stuff or this kind of thing, the message box A is going to be your best friend. Because that's often you can't debug into these applications or do like debug stepping. So putting up a message box is going to be very common, can be very helpful. But if you can debug, wonderful, good stuff. So the first thing we do is to hook create device. So this is the first bit of sneaky stuff I do, is I create the DirectX 9 device, okay? Do I care about this DirectX 9 device? No, I only want the virtual function table. So I get the address, which is I love this cache, that dereference a dword star, but get the dword star, which kind of, yeah, gets the thing extracted, and yeah, now I have a pointer to the virtual function table, and then I release the device, because I don't care about the device. I only care about where in the address the virtual function table is. And then I have a little helper class for VM protect, and then I know where in the virtual function table the create device function is, because it's always the same offset, so I know the offsets that I'm going to save. So I have that saved somewhere. The size of it is a dword. I want to make that read and writable, because it's not read-writable to begin with. And then this is the action, little lambda. This is the action I do. So I save the original function pointer, and then I put my create device hook into that address. So again, I want to know what their function pointer address is, and I replace it with mine. So when they call their function, they're actually calling my function. And fun fact, if you run things like OPS or Fraps or any kind of these applications, they are all doing this and replacing. So when you're running applications and someone is calling a function, it might actually go through a few layers of these indirects or redirections. So they're all thinking they're very sneaky, but they're just replacing the other application's pointer and whatever. So everybody is being very sneaky. All right, so summary. Spawn the game process, it's paused, good. Attach.dll to the game process, we've done that, good. Hook the create device function, okay, it's now hooked. Then, once the game calls the create device function, we just get the device that they made, because we make it for them, and we hook the end scene function. We can't do that in the beginning because we need the actual device they're using. For the create one, that's a function pointer we can replace initially. So this is the create device hook that the game will initially call. And of course, we're being nice, so we just create the device for them. That's good stuff. Have a little error message. And then I make it reroutable again. So I'm a nice boy, and I put the memory back. And then I get the vtable of the device that I just made. I get the end scene function pointer. So for those who don't know, end scene is the game sets everything up, makes everything ready, and then when they think they are ready with the data that they want to show, they say end scene, and that data is then sent to graphics card or wherever you want to send it. So that the end scene is basically draw the things that I just made. And then I put my function there. All right. And then, yeah, we get a message that says game rendering hooked. I really like that it has already loaded 3% of the game when that happens. I don't know why that is, but I think that's very funny. So then I now have a function that's called every frame. Every time a new frame is being rendered on the screen, I have a function that's being called. All right? I call the actual render frame, because, okay, I'll be nice with them. And then I can just count. I have a static variable in my scope that's just there. And then in frame 1, you go back to our good old friend, the Windows keyboard API, or all that stuff, and I say, press the spacebar button. On frame 2, release the spacebar button. And this works. This will then press the spacebar and release the spacebar the first frame possible. Okay, so what can we do with that? Well, we can make the function a little bit more complicated. I load data from a very complicated file format that I made that looks something like this. So on frame 1, don't do anything. On frame 2, there's a big S, so we press S. On frame 2, there's a little s, so we release S. And then I can just describe every frame, what I want to happen perfectly every frame of the game. So then I just go through the file and ask like, hey, on which frame are we? Cool, get that line from the file, press that button. If it's a dash, don't do anything, right? So, who wants to see a demo? Yeah, here we go. Here we go. Let me see, close this. So, load there. Let me maybe minimize this so it's simple. So it plays the game. Again, yeah. And then it goes perfectly there, avoids the, goes up there, and then it ends there. Don't do anything else. You can see in the top corner, there's a little debug window. I can see what frame it is, and I can see how many milliseconds each frame took. And I have a little button UI where I can press, and I can slow down. Because I can just put a sleep. So just sleep X amount of times, because every time the new frame is called, that's what I increment the counter. So we can slow it down even more when I go down. So this is how I built the files. I'm like, okay, on frame 219, I should press space. On frame 222, I should press this button, right? And then I can see that, up. I hit the wall, so I went there. So this is how you can play it. So then, I make a few. I think it's train get. So I play the difficult challenges of the game, and then I get the cool trinket, right? For those who've played the game, they know that it auto saves every time you collect one of these. But if I run it again, I can go and play it again, and you can see the trinket is still there. Because I have the save files, and I overwrite the save files every time I do this. So I have the actual save state of each thing. And the fun thing about this, maybe do it this way. No, I think I hit a button, sorry. Yeah, I hit some buttons. It can be kind of finicky sometimes. So, I want you to look at how this is running. And then, 1 frame a second, I promised you in the title, there's a thing called coyote time in video games, which means that you can actually press spacebar or like jump or whatever after you've, okay, it was pretty close there, right? But you can actually press the buttons after you've left the, and then space. It's called coyote time. Who thinks why it's called coyote time? Wile E. Coyote, because, oosh. It's pretty fun. So it's a fun thing to play with. For those who have played this game, you're going to be very annoyed with me right now. And then, yeah, okay, I get it. I get the trinket. Because you can't jump, and there's a little box, so you have to jump all the way up and down and try to get the thing. So this is the hardest challenge in the game. It still took a little while to make, but it's, playing games 1 frame at a time. So, to summarize, here we go, good time. Games are neat, right? Yeah? Yes, thank you. And it's fun to play with them programmatically. So, when you have an application and you don't have the source code for it, there are still ways to automatically interact with it. AKA, yes, you can still test that old legacy app. So yes, this has been a testing talk. Welcome, you were at a testing talk. And yes, you can still do the save refactoring because you can do the approval test and you can know a lot of things about the application. So write more tests. For those who are curious about this kind of gaming thing, for those who have never seen these tools, so there's this whole section of things called tool-assisted speedruns, which go over all these games and play Mario, Pixel Perfect, and all these things. On Task videos, there's also on YouTube a bunch of videos if you want to watch. There's this whole community that you can now obsess over, just like I do. They play on all of the operating systems and consoles and play all the games, and people are always absolutely obsessed with this. And they're way better at this than me, and they make way better code than I do. Because they have these tools. They do this stuff. What I've been doing, they do some of it. Some of it, they can do it because they have the emulator, so the emulator supports it. So it's through the emulation, not through the hooking like I'm doing. For those who are curious about Doom, there's called a Doom speed demo archive. And it's actually them that I used some of the tests from the earlier, because they have a bunch of the edge cases. So they know the little quirks of the engine, and they have demos of the quirks. So some of the quirks I actually have in my test, just to see that the quirks are still there and they're still behaving correctly. There's even a demo in there that like the person is playing for like 8 minutes, and it runs in like a few milliseconds, the whole thing. So if you're curious, there's Doom and Classic Doom. These are the repos. It's usually me, and then I have some stuff under it. And the Doom one is under Patricia Oaz's repo, if you're looking for that. And then that's my face again. Thank you. So, any questions, comments, angry rants, dad jokes?
Yeah. I'll just mention it probably since that, but maybe other people didn't. So in Doom, right, they are using this kind of techniques to find things. So they fuzz that old binary or whatever. And like, for example, discover how you can kill all the monsters in the room where you're not supposed to kill all the monsters and that kind of stuff.
Yeah, and there are people who are trying to beat the game without killing any monsters, called pacifist. And there are some levels where you like can't, but they found like if you stand here and look at this pixel perfect angle and you do some movements, you'll teleport through the wall and like. And they didn't find it. They used like almost like a machine learning of like iterating through and like finding weird behaviors, and yeah, people are going all out, absolutely all out. So if you want a rabbit hole that's very deep, Doom speedrunning and Doom things are very deep. Any more comments, thoughts, angry rants? I think it's Sunday. I think people want to do something else. You can also yell at me if you see me somewhere. All right. Anything from online? No? Awesome. Then thank you very much and have a lovely evening.